Hi guys, I hope you are able to see me. Let me just have a look in the feedback. So today's topic, I guess you would know, it is electrostatics. Let's see. Still loading. Yeah, electrostatics. Let me just check if I'm live. My video seems to be fluctuating. Let's see. If it fluctuates a lot in the middle, I'll just start using my mobile data if required. For now, let's just keep stuck to this. Could you guys just put in the chat if you are able to see me / hear me, because the feedback on my app has still not loaded, so it would be great if you could tell if you are able to hear me or not. Until then, I'll just check if the quiz is loaded on the portal. I guess the quiz key has changed. Okay, that is why. 1 minute. Yeah. For people who are on YouTube, if you want to join this quiz right now and if you want to attempt, you can do so by downloading the tuition.in app. Okay, I have the quiz in front of me. Hello guys, I hope you are able to see me and hear me. Could some of you just put in the chat if everything is fine, audio and video, because I'm not sure whether people are seeing and hearing me. I can see myself on the feedback app, but yeah, I would just need your confirmation to begin. Okay, I'm not sure. Maybe I'm just able to see like 1 or 2 messages, I guess, on the app. Never mind. I think I'm good to go. I think I'm out properly in terms of video and audio. So I'll just start with the first quiz here. First question of the quiz here. So as you guys know, today's topic is electrostatics, right? Electrostatics up to Coulomb's law and electric field. I guess we have some questions from electric field also. In the next part, we will have electric potential and relation between electric potential and electric field type of questions. And in the third quiz of this one, we will have Gauss law and all those things, like the last part of the chapter or whatever is remaining, right? So that is more or less the schedule for the next 2 quizzes for the second years, and for the first years I'll let them know in their quiz. So let me just show the first question on screen here. What is the smallest electric force between 2 charges present at a distance of 1 meter, right? Okay, the best hint for this question, I'm talking about the smallest electric force here, right? And then looking at this, what should come to your mind is the Coulomb's force equation, right? K q1 q2 by r square. R is already fixed to you. K is already a constant. So how do you minimize that force? The only way you can minimize that force is that if you minimize q1 and q2, isn't it? So how will that be? Imagine the smallest charges possible, right? So let's just trigger the first question so that people can attempt it, right? Think of what is the smallest possible charge in order to answer this question, right? Usually the first question takes a little time to come on screen. For guys who are on YouTube, if you hate waiting, then maybe you can just let the quiz finish and come back and watch this video and forward the parts wherever there are gaps. And for the next few quizzes, you can obviously download tuition.in app, since these quizzes are free and the questions are quite interesting. I'll explain the concept behind every question and also solve it for you after the answer is out. So 2 minutes of time to solve this one, right? So we've increased the time given per question because we've realized that some questions are quite time taking, and we were giving like 1 minute or 30 seconds. We were giving like 50 seconds per question, which was definitely not enough for a lot of questions. For something like this, it's a very easy one. But yeah, more 1.5 minutes to go. Right. Let's see how many people get this one right. Okay, I've already given you the hint for the question. And since the time has increased to 2 minutes, so what I will do is I will just display the question to you, and while the timer is going on, I will give you the hint and you can continue solving, right? Because 2 minutes is, I think that is what the actual time will be when you attempt your JEE paper. At least in our time, that's how it was: 30 questions per topic, per subject. 30 plus 30 plus 30. We had 90 questions, 180 minutes. So it was roughly like 2 minutes per question. That's how it was, right? So 50% people have got this right. That includes my response also. I'm not sure how many are watching, but anyways, let me just go back quickly and explain it to you, right? So let's just draw here on the screen, right? Yeah. Okay, so I've already told you force is nothing but, Coulomb's force is nothing but K Q1 Q2 by R square. Since we are only talking about the magnitude of force, I will just take the magnitude of this whole thing, right? So K is already a constant, R square, it's already given to be 1. So we can't do anything about it. What we have to do is we have to minimize this. We have to minimize this to get the minimum force. How do we minimize this, right? So smallest possible charge. What is the smallest possible charge? Charge of an electron, 1.6 into 10 power minus 19 Coulomb with a negative sign. This is the smallest possible charge, and the smallest magnitude possible is this, right? Okay. The internet connection seems to be fluctuating. Okay, let's do one thing. Let's just switch to my mobile data. Yeah, I guess now we are fine. We won't be having any interruptions, hopefully. If this also gets interrupted, then we can't really help it. All right, so 1 minute. Let me just key it properly so that, with every change of dress, keying has to change, as I had told you before. Okay, so I was here, right? Yeah. Okay, I think this part is not visible, right? So I'll just hide myself. Yeah, so that you can see the explanation properly. Okay, so this is the smallest possible charge. Okay, and if you want this product to be smallest, then both of them have to be this, right? So if you do Q1 Q2, you will get 2.56 into 10 power minus 28 Coulomb, and that you have to multiply with K by R square, and obviously when you do that, you will get the answer to be this, right? 10 power sorry, this is the number 10 power minus 38, not 28. You have 19 here, right? So then when you do that, you will get this as the answer, right? Calculations, I'll leave that to you. Let's get back to the next question. I'll get myself back on screen, right? Question number 2, I'll just display it and at the same time trigger it, because we have enough time now. So here is the question on your screen already, and here it is on your what do you say? Okay. Right, so I've already triggered it on the app. I guess I'm not able to see it because I had to quit the app for some reason. So once it's done, I'll just have to roughly see when it's done, and then I'll explain. Right. It's a very simple question, guys. Again, you don't even need 30 seconds to answer this if your concepts are clear. Because what is it saying? Charge on Q1 due to Q2 is 4i plus 3j. Sorry, force on Q1 due to Q2 is 4i plus 3j. Then what is the force on Q2 due to Q1? Right. Pretty simple question actually. And as I told you, if concepts are clear, it's not going to take any time, right? So I'm not really sure if the timer is done. I'll just wait for like 30 seconds more because I'm not able to see on my screen whether it's done or not. So I'll just start explaining it once my clock hits 8:13. From what I can see, we have slightly less crowd for second years, right? Mostly because people were not informed about the quiz. First years do have an idea about this quiz series. So of course, for those of you who are on YouTube, now you guys know that we have quizzes for second years and first years happening. So keep the app installed and put your notifications on YouTube. Subscribe to tuition.in channel and put your notifications on so that whenever we host a live quiz, it directly comes on your phone, right? I guess it's 8:13. So now I will just start explaining it, assuming that the time is done. Okay, so this is Q1. This is Q2. What's given in the question is force on Q1 due to Q2 is this. Excuse me. Yeah. Let's say this is the force, right? Let's say Q2 is attracting Q1. Okay, then this will be the force, 4i minus 3j. The question is, what is this force going to be on Q2 due to Q1? You should always know that this Coulombic force on two different charges will occur in pairs, right? Equal and opposite pairs. So force on Q2 will exactly be the opposite of what force on Q1 was due to Q2, right? So if this is vector A bar, if A bar is the force vector on Q1 due to Q2, then force vector B bar on Q2 due to Q1 will simply be negative of A bar because it just has to be opposite, right? In terms of direction, magnitude has to be same, it should just be opposite. So what is the answer to the question? Answer to the question is simply minus of 4i minus 3j, right? I think that's option B. That is the answer to the question, guys. And yeah, let's now move on to the next one, right? So I'll just go on the full screen mode, display it, take you to the third question, and this is slightly time taking. You have a charge placed, you want electric field at a certain point. It's actually very direct, it's just from the definition, right? If you know the definition for electric field, if you know how to calculate it, it's a very simple question. The only tricky part here is the question is slightly time taking, right? That is the only thing. Okay, I went offline. Sorry about that. I don't know if my audio is out. I'll just check my camera connection once. I guess that's also stuck. Yeah, I think it's back. All right. So I guess I have triggered the question for you, right? Okay, it's not triggered. Now it's up. Okay. So I think you guys had enough time to read the question, and now you can simply attempt it, right? So you should just have a basic idea of how to get electric field vector, right? If I give you a charge and if I give you a position, right, a position from that charge, then how do you calculate electric field vector? That is the question. So the question is just lengthy in terms of calculations, as I've told you. Again, I'm not really getting a feedback, so I'm not sure if I'm out. If the options are, if the explanation like time is done, right? Let me just, let me just start explaining once the clock hits 2018. You know, I hope the connection is not fluctuating anymore. I don't know, it's even difficult to predict when will the internet go down these days. And it just goes out for like 2 to 3 minutes where it just gives us slight trouble, and then once it's back, it's good for the entire session. So, you know, can't really help this one. Okay, the clock has hit 2018. So let's look at this question. This question number 3, I guess. Yeah. So you have a charge given to you, right? 1 microcoulomb, and you have the coordinates of the point where the charge is present, 1, 2, 4, right? You want to know that at a point P, which is 0, minus 4, 3, what is the electric field, right? How will you get it? How will you get the electric field? So what you have to know is electric field vector will have 2 parts. It will first have the magnitude, and then it will have the direction, right? Magnitude plus direction. In fact, we don't represent vectors as magnitude plus direction. We represent them as magnitude into direction, right? That's the representation. In fact, let me just add one more slide to this, because it's going to be slightly lengthy. I won't calculate the whole thing, but anyways, I have to give you an idea, right? So 1 microcoulomb, and here we have 1, 2, 4. Forget this. 1, 2, 4, and there we have 0, minus 4, 3. And this is a point P, right? So if you need this electric vector, right? First of all, it's given that it's a positive charge, and you should know if it's a positive charge, then electric vector will point away from this point. Electric field vector will point away from this particular point, right? But the question is, how do you get this? This vector has a magnitude and it also has a direction. So first of all, how do you get the magnitude? To get the magnitude, you need the distance between these 2 points. How will you get the distance if you have the coordinates, right? Distance r, let's say the distance is r. If you need the magnitude of the distance, that is simply root over 1 minus 0 whole square plus 2 minus of minus 4 whole square, just subtracting the coordinates, right? This is the distance formula that I'm using. I hope you guys know this, right? Plus 4 minus 3 whole square, right? And if you do this, you'll get 1 square plus 4 plus 2, 6 square, which is 36 plus 1, right? I think it's root 38. Is this right? Yeah, it's right. Okay, root 38. That is the distance. How will you get the magnitude? First of all, magnitude is k times q by r square, right? That's the electric field's magnitude. So k is 9 into 10 power 9. Q is 1 microcoulomb, so 1 into 10 power minus 6, right? 1 microcoulomb, yeah, and r square is root 38, so 38, right? This is the magnitude. But the question is, the real difficult part is, how will you get the direction? Direction is always represented in the form of a unit vector, right? So to know direction, you have to understand the concept of unit vector. So what is the unit vector? If I have a point A, B, C, and the other point is, let's say this is A1, B1, C1, and the other point is A2, B2, C2, then how will I get the unit vector starting from here and going there? Unit vector is a vector which is having magnitude 1, that's all, right? And pointing in a given direction. How will I get this vector? So unit vector is, let's say the unit vector is A cap, right? Typically you represent unit vectors with a cap, okay? And the formula for that is simply magnitude of A, which is length of A. This is A bar divided by magnitude of A. This is unit vector, right? A bar vector divided by the magnitude is the unit vector. Simple. So how will you get A bar vector is A2 minus A1 I cap plus B2 minus B1 J cap plus C2 minus C1 K cap. This is the A bar vector. And how will you get the magnitude? Length is simply under root A2 minus A1 whole square, right? You have 2 points given on the vector. How will you get the distance between them? Use the distance formula. This is one of the most basic things, right? B1 minus B2 whole square plus C1 minus C2 minus C1 whole square. C1 minus C2, C2 minus C1 doesn't matter, right? So this is going to give you the unit vector. So if you need the unit vector in this direction, you will just do that, right? So what is the UV unit vector? Unit vector is simply this is 1 minus 0 I cap plus 2 minus of minus 4, which is 6 j cap, plus 4 minus 3, 1 k cap. This is the unit vector divided by the length. Length of this vector we have already calculated, root 38. So if I need the complete E bar vector, I'll have to multiply this quantity with this magnitude. So whatever magnitude you get from here, calculate it, multiply that with this, and then if you multiply, you will have 3 individual terms. You'll have to multiply with I component separately, j component separately, k separately. Do those calculations for yourself, and once you do them, I think, let me just confirm the answer. This will be minus 38.42 I cap, all 3 minus, right? I think that's option D, right? That will be the answer to the question, this one, right? Okay, I think we are good to go with this. Let's move on to question number 4 now. And I believe there are no connection interruptions happening. So let's go to question number 4 and let's trigger it. Right. 2 positive charges, Q1 16 microcoulomb, Q2 4 microcoulomb, are separated at a certain distance. Find a point on the line between the charges where the net electric field is 0. Well, you should find a point between 2 charges where the electric field is 0. How will you do that? You should know that electric field at a point due to 2 charges is the vectorial sum of the electric field due to each charge individually. This is also known as principle of superposition. So what you will do, if you have a point and 2 charges, first forget one of the charges, take only one charge, calculate electric field at this point due to this charge, right, vectorially. Then forget this charge, bring the other charge, calculate electric field at the same point due to this charge vectorially, and then add these 2 vectors, the previous vector and this vector, to get the net electric field. What you have to do is, you have to find this net electric field and equate it to 0, right? And if you do that, that is when you will get the distance where this electric field becomes 0, right? That's the best hint that I could give you. In fact, I explained you the solution orally. So for those of you who already have a certain grip from the concept, you guys would have caught it by now. And if you did not, then we will anyways look into it. So I'll quickly give you an idea. Again, I will not really solve it. I'll leave the calculation for yourself. Last 30 seconds to go. Less than 30, I guess. Looks like it's almost time. So let's just go and look at the explanation now. Right, question number 4, here it is. Okay, most people have got this one right. Let me just add another slide and explain this to you. So you have 2 charges. First is Q1, which is 16 microcoulombs. Then you have Q2, which is 4 microcoulomb, and this is the line joining these two. Take a point, assume a point P in between them. Let's say that this P is at a distance x from Q1. Okay, so how do you get the electric field at P only due to Q1? If you want to get the electric field only due to Q1, first of all you have to know that, okay, if it's a positive charge, then electric field will point away from that, right? If it's positive, then electric field will point away. How will I get the magnitude of this? How will I get the magnitude? So it's simply K into Q, which is 16 microcoulomb, divided by R square. R is x square, right? This is the magnitude of this electric field. Now what I need is the other electric field due to Q2. That electric field, because this is 4 microcoulomb, again positive, so this electric field will point away from this charge, right? Whenever your charge is positive, electric field will point away. Okay, so this is and what is the magnitude of this one? The magnitude of this one is simply K into 4 microcoulomb by, what is this distance now? What is this distance? 1 minus x, right? What is the distance between these two guys? Oh, 3. So 3 minus x. This is 3 minus x whole square. Now, if the net electric field has to be 0, then this black electric field and red electric field have to cancel each other, right? If they cancel each other, that means their magnitudes have to be equal. Only then they'll be able to cancel out each other. So I can simply say that k into 16 microcoulomb divided by x square should be equal to k into 4 microcoulomb divided by 3 minus x square, right? And the square will cancel out, k will cancel out, microcoulombs will cancel out, and like just solve for x, right? If you solve for x, what will you get? The answer to the question is 2 meter from q1 and 1 meter from q2. 2 meter from q1, right? Oh, I just displayed another question. 2 meter from q1. So that means this x will come out to be 2, right, when you solve it. Yeah, I think that's all. Let's move on to the next question now. Question number 5. Time to see that. Just have a read until I go and trigger it. Electric field of this particular magnitude points due west at a certain spot. What are the magnitude and direction of the force that acts on a charge of plus 2 microcoulomb and minus 5 microcoulomb at this point, right? Again, literally the question is from the definition itself, so shouldn't be very difficult for you. Okay, so you have a charge, you have the electric field given at that charge, right? You just need the force on two charges, right? First you will put plus 2 microcoulomb, and you need the force that this charge will experience at that point due to this electric field. That is first part. Then you will remove this part plus 2 microcoulomb and you will bring minus 5 microcoulomb. You will put it there, and then you want the force that acts on minus 5 microcoulomb due to this given electric field, right? And you just don't need the magnitude, you need it vectorially. Actually, it's a pretty direct question. Again, it's like a 1 minute question, or not even 1 minute, it's like a 40 seconds question, right? Okay, I think it's already done and some people have made an attempt. Okay, so if it's already done, let's go and quickly look at the solution. Question number 5. Here it is. Let me just add. Okay, I can just explain it here only. Okay, so you have, let's say this is your point. Okay, on this point, what do you have? 10 power 5 Newton per Coulomb. This is the electric field's magnitude, and it's pointing towards west. If it points towards west, that means it's pointing in this direction, right? And the magnitude of this electric field is 10 power 5 Newton per Coulomb. Now, let's say if I bring plus 2 Coulomb and if I place it here, then I know the electric field at that point. How will I get the force? If I have a charge Q, if I know the electric field at a given point, and if I place this charge here, then what is the formula for force on that charge? It's simply Q into electric field vector, right? Q into electric field vector. That's all, right? So force on plus 2 microcoulomb, what will it be? Charge into, did I say force into? I was wrong. Charge into, so charge is 2 microcoulomb into electric field, right? And that is 10 power 5 Newton per Coulomb, and this is towards west, right? So force will be, what is it? 0.2 Newton. Coulombs will cancel, right? And you'll have 0.2 newtons towards west. So force on plus 2 microcoulomb is 0.2 newtons towards west. What about force on minus 5 microcoulomb? Again, the same formula. Charge into electric field vector. Charge is minus 5 microcoulomb. Electric field vector is 10 power 5 Newton per Coulomb, the same towards west, right? But what will you have? You'll have minus 0.5 newtons towards west, right? On this guy, on minus 5 microcoulomb. Minus 0.5 towards west means I can also say it's 0.5 newtons towards east, because minus, if you take the minus will always go into direction. Minus will never remain with the magnitude. Minus will just swap the direction. So from west it will make it east, right? That's why the answer to the question is option A, I guess. 0.2 Newton on plus 2 and 0.2 Newton west on plus 2 and 0.5 Newton east on minus 5. That's the answer. Okay, I guess this is done. Let's go to question number 6 now. Right. Okay, this is slightly conceptual, right? Let's go and trigger this one. Again, you will not really be needing a lot of time for this. Again, 1 minute is pretty sufficient. 1 minute is pretty sufficient to answer this question, right? Okay, there also could be a mistake in the key. Is it? Ah, no, not really. Okay. Pretty simple this question, guys. Straight away from electric field lines concept. Right, you should get it right in just one step, you know. I wish I had the option to close the timer manually for certain questions, right? In fact, we'll try adding that feature so that I can control the time looking at the level of the question. Okay. Oh, that's great. The quiz has, concluded. Okay. People have gone for both positive. No, guys, it's not both positive. Let me just quickly come here and explain. Let's come here. All right. So as you can see, the field lines are coming into the charge, right? So just a simple rule. If you have a positive charge, then field lines will always go away from it, as we have been seeing in some previous questions. If you have a negative charge, field lines will always come into it. As you can see in both Q1 and Q2, field lines are all coming into it. Look at the arrows. Field lines are all coming into, right? Now, why they are curved is a different thing. They are curved because they are placed towards each other. If I only had a Q1 here, then field lines would actually look like this. They would be like straight lines. If I only had Q2, then it would come like this. But if I bring these two close, then these lines will become curved, because some of these lines in this area have to cancel, because common charges, right? They will have to, leave some empty space. That's why Q1 and Q2 are both negative, because I don't know about their magnitudes, but both of them are attracting field lines. So in that case, both have to be negative. Pretty simple. Let's go on to question number 7 now. Let's look at the 11. Okay, this is also a 1 minute question, slightly more involving than the previous one. So just, the best hint that I can give you for this is, think of a formula for the time period of a pendulum, right? The formula for the time period of a pendulum, if you don't know, it's t is equal to 2 pi root L by G. Think of how G will be affected when this happens, right? Think of how G will be affected. Okay. That's the hint, and now I can trigger it. Again, it's a 1 minute question. Let's see how many people get this one right. I believe a lot of you should get it right. Right. Acceleration due to gravity. Time period t is equal to 2 pi root L by G. Now, why is that formula having G? So, to solve this question, that's why it's a second year quiz, because I believe that you guys would have finished simple harmonic motion. You guys would have derived the formula for time period of a simple pendulum. If you understood that derivation properly, you would know what is G there. And then when you look at this, you should be able to relate that with this, right? Look at the diagram in the question, right? Right, 1 minute, 28%. People have got it right. It looks like an equal division. All right. Okay. So let's go. Let's look at it on the screen itself. Question number 7. Right. So what will happen on this ball? This neutral pendulum oscillates, in a uniform electric field as shown. If a positive charge is put, so what you're doing is you're putting positive charge here. If you put positive charge here, then electric field is pointing up. So electric field here also will point up. If electric field is pointing up, then this charge is going to experience an upwards force, right? Fe, right? It already was experience mg down, right? So when the pendulum was completely neutral, the formula was 2 is equal to 2 pi root L by G, where G was the acceleration downwards, right? But when this Fe will come into picture due to the electric field and charge, what will happen? what will be the net acceleration downwards? A net, what will it be downward? It will be force net divided by mass. So net downward force is going to be mg minus fe by m. This is going to be the net acceleration downwards. So the net acceleration will not be g anymore. It will change to g minus fe by m. Correct? That's what it will become. So time period's new formula will be 2 pi under root L by g minus fe by m. Okay, now look at what is happening here. G minus fe by m. So this term is decreasing, right? G minus fe by m, denominator is decreasing. If denominator is decreasing, then this whole term will increase, correct? If denominator is decreasing, then this whole term will increase, and that is what I'm saying, time period will increase, right? That is the formula for the time period. That's how you relate one topic from another. That's how most of your JEE questions are going to be. They're not going to be limited to one chapter. They're going to link concepts between chapters, and then you have to have clarity on all concepts individually. Okay, so let's go on to question number 8 now. Question number 8. Okay, this anyways, you will get it on your app, right? 4 positive charges 2 root 2 minus 1 q are arranged at the corner of a square. Another charge q is placed at the center. The resulting force acting on each corner charge is 0 if q is, right? Just a direct superposition of electric fields question. You would need 2 minutes for this. You would definitely need 2 minutes for this. Yeah, so look at the options on screen. If you guys want, I will write the options also. In fact, I will explain the question since some of you might not be able to see it clearly, right? You have 4 charges. Here we are. 4 positive charges. Each charge is having 2 root 2 minus 1 q magnitude. And in the center you place some charge small q. And then you want to know for what value of q the net force on each corner is going to be 0, right? So first option is minus 7q by 4. Second option is minus 4q by 7. Third option is simply minus q, right, capital Q. And fifth option is minus 2 into root plus 1 by q, right? I think it's plus 1 only, yeah. Option 1. Right, straight away a question from electric fields, superposition of electric field. We will quickly look at the explanation. Don't worry about that. Again, I'm not going to completely solve it because the calculation is something that's rather left to you. But the concept is what you need to know for questions like these. For those of you with a poor internet connection, the question would be very hazy. You will hardly be able to see it from a computer screen. That's why I explained it to you verbally as well. Okay, let's just go on a new slide and look at it. Right, so we have 2 root 2 minus 1 q on 4 corners, 2 root 2 minus 1 q, and if you have a pen and paper, just don't look at it, just start drawing it by yourself. So what will happen, let's take one and we are placing a charge small q here, okay, and we want to know for what value of small q the net force here will be 0. Just pick up 1, right, and make the net force 0 and 1, you will get small q. Okay, so because of this guy, the electric field is going to be outwards, right, because this is positive, right, and this is also positive, so force is outwards. Because of this guy, it's going to be like this, outwards, and because of this guy, it's going to be outwards like this. So we need the magnitude of these 3. We need to find the resultant, right? We need to find the resultant, and we need to find that q. So this q is also going to apply its own force. So we can clearly see that this vector this vector, and these three will add up to give something in this direction, right? You should know vectorial addition for this. So this small q should be such that it puts a force in this direction, so that resultant is cancelled with this, right? So if I just get the magnitude of this, like up arrow, what is the magnitude, what is the distance, right? They are okay, let's say the distance is a here, right? So what is going to be the magnitude of this and this, right? So it's going to be k times 2 root 2 minus 1 q whole square divided by a square, right? In fact, I have two forces like this. This one also will have the same magnitude. This will also have same magnitude. So net resultant will simply be root 2 of this, right? It's simply going to be root 2 of this. That's a vectorial trick. You should know that. And then I will find force due to this, and that will also be in this direction. So this vector, this root 2 of this vector, and the force that I get from here, these two will add up, right? And then you calculate that yourself. And then what will be the force due to small q be? What will be the magnitude? It will be k times q into 2 root 2 minus 1 small capital Q divided by, this is going to be root 2a by 2, right? This length is going to be root 2a by 2. So it's root 2a by 2 whole square. So that magnitude, you will have to equate the magnitude that you get, equate with the magnitude that you get by adding this force, and the force due to this third charge, right? So when you do those calculations and when you try solving for small q, what is it that you will get? You will get minus 7q by 4, right? I think that's the answer. Let me just confirm. Yeah. Okay. So let's go on to question number 9 now. I know this question has, some of these are slightly lengthy in terms of calculations. Question number 9 up on your screen. Again, I'll have to write it separately because maybe you'll not be able to see. So first I will write it and then I will leave it. Okay. So a proton is released from rest. So here is your proton. It is released from rest 10 centimeter from a charge sheet. So you have a charge sheet here, right? At a distance of 10 centimeter, you release a proton, right? Charge is carrying a charge density of minus 2.21 into 10 power minus 9 Coulomb per meter square. Okay. It is going to strike the sheet after a time. Oh, well, actually this question shouldn't really have been here. It's my mistake, it's out of the portion for today because it's coming from sheets and Gauss laws and all, right? You need to know Gauss law to solve this. Anyways, since it's come up, we'll just look at the solution. Okay. I expect you guys to solve this because it was not really there in today's portion. Okay. I guess I've triggered the options. Anyways, for those of you who can solve it, just try. You want to know that after how much time approximately will this proton strike this. First of all, why will it strike? Because this has a negative charge. There are all negative charges here. So all these negative charges will create an electric field towards this side, right? So proton will experience a force towards left. So proton will start accelerating towards left. But the question is, after how much time will it strike the surface? So if you know the acceleration, right? The hint is, if you know the acceleration, you need 2 minutes, by the way, for this question. So if you know the acceleration, you have the distance with you. You just need to know, you just need to use, what will you use, which equation will you use? S equal to ut plus half at square, right? Because u is 0, proton is starting from rest, that's given in the question, right? A is what you need, that you can get from this, right? If you know Gauss law, then you can get it from this. And then that's all. From there, you have the distance, and you just need to find out time, right? By the way, what is this? This is a charge sheet. Yes, just like 10 more seconds to go. Okay, 50%. Okay, not bad. By the way, I think I forgot to tell you the options. This was 4 microsecond, this was 2 microsecond, this was 2 root 2 microsecond, this was 4 root 2 microsecond. Okay, so how do you get, what is the point now? You have a proton, you know the distance 10 centimeter, and you want to know after how much time will it strike. So there will be a force that the proton will experience towards the left side, and if I can get the acceleration, how will I get the acceleration? QE by m, right? QB by m will be the acceleration. QE magnitude is the force magnitude, electric force by mass. So charge of proton is 1.6 into 10 power minus 19, right? Electric field magnitude, how will you get? That is why you need Gauss law for this question. If you have sigma, then sigma by 2 epsilon naught is the electric field due to a plane sheet of charge. This is what you wouldn't know unless you know Gauss law. So sigma by 2 epsilon naught, right? So sigma, and you need the magnitude, right? Because you need the magnitude of QE here. So sigma is given to you 2.21 into 10 power minus 9 divided by 2 times epsilon naught is 8.85 into 10 power minus 12, as far as I remember, right? This is it, and this divided by mass is 1.6 into 10 power minus 27. That's the mass for proton. So this whole calculation is going to give you the acceleration, right? Once you get the acceleration, you will just use this s equal to ut plus half at square, where your u is 0, right? Because proton is starting from rest. Distance to be covered is 10, right? So distance is 10, half into acceleration you will get from here. When you put that here, and t square, right? You just have to find t from this, and when you do that, it will roughly come out to be 4 microseconds, right? So yeah, slightly involving question, also requiring Gauss law and also, you know, lengthy calculations. But yeah, you will anyways get 2 minutes only in the actual exam also. So if you knew Gauss law, the time given was fair, because that's how you have to practice. You know, you have to get yourself to the level where you are able to solve questions like this in 2 minutes. Never mind. Let's move on to the next question now. And since it's not typed, I'll just display it here. So a pendulum bob of mass m. So I'll just dictate it and then give you the time. Or maybe it's a simple question. So I'll give you 2 minutes. But at the same time I'll dictate it while triggering. So I've triggered the options, and now listen to the question. So you have a pendulum of mass m carrying a charge q, and this pendulum is making an angle theta with the vertical. So this pendulum is making an angle theta with the vertical. So you need the tension in the string. First option is mg by sine theta. Second option is mg. Third option is qe by sine theta. Fourth option is qe by cos theta. Which of these 4 options is your tension T? Assume that this whole thing is present in gravity. By the way, what's also given is it's placed in uniform electric field E. So this is your electric field E, right, towards the left side. That's why it's tilted like that, right? So charge is given, electric field is given, mass is given, and it's also given that this is placed in gravity. Theta is given. How do you find T? So this is, there are 2 things involved in this question. First is your electrostatic concepts, and the second is your Newton's laws of motion. Equilibrium from Newton's laws of motion. That's to be more precise. All right. So try. We have like 30 seconds more to go. As you can see, the internet connections interruption was only a thing in the beginning. Once it settles, then it remains settled for the rest of the session. So minor fluctuations we can't really help. Anyways, let's see. The explanation to this question is going to be very simple. I guess it's done. Time up. Yeah, so how do we begin? So basically, just look at this diagram. What are the forces acting on this? You have mg acting downwards, you have QE acting towards left, because electric field is towards left and this is having a charge Q, so force will be QE towards left, and you need tension, right? How will you get tension? So there's one very simple thing you could do. You can split tension, right? So if this is theta, then this is also theta, right? So this up component will be 2 cos theta. Vectors, guys, vectors is very important, as I've been telling. And the right component is to t sine theta. T cos theta up, t sine theta right. So t sine theta is going to balance out QE, t cos theta is going to balance out mg. So you can say that your tension is either QE by sine theta or it's mg by cos theta. So option 1 is mg by sine theta, so it's wrong. Option B is mg, which is absolutely wrong, right? Because for it to be mg, for answer to be mg, it should have been like this: no electric field. Bob should just be hanging, making an angle 0, and then this would be mg, this would be tension, then tension would be mg. But since there is a tilt here, tension can't be mg. That's why this is wrong. QE by sine theta, well, this is right, yeah. So this is the answer. QE by cos theta, obviously wrong, right? So as you can see, we are done with the session today. I hope you guys had fun and enjoyed learning. There were some technical glitches, but as you attend more and more quizzes, you will get used to them and you will realize that there's nothing to panic. It just stops in the middle and we come back and we resume, right? So see you guys again next time. I'll share the schedule on weekend, Sunday, right? The next 2 quizzes that we will have will also be on electrostatics for second years, right? You'll get that by Sunday. Please download the tuition.in app to attempt all these quizzes for free, and switch on your YouTube notifications so that you get notified the moment any quiz is hosted. And yeah, do keep sending us your feedback either in the comments or just mail it to tuition.in. So until then, see you guys again next time. Thanks for joining in. Bye bye.